Alright, so just put a pen down for us. I'm just going to go through some bearings. Just because I think this is an area we're struggling with a little bit, and it's one of those things where we sort of teach you in grade 9 and 10 and then we don't look at it as much as we should, unless we're doing general maths, in which case we should be guns at it. So for our bearings, we have two types that are commonly used, our compass bearings and true bearings. Compass bearings are the ones where we've got two directions. True bearings are often shown by T. The clear difference between them is that our true bearings start at north and work clockwise. So if we've got 312 degrees true, we start at north and we work all the way around 312 degrees. What's the largest bearing we will get for a true bearing?
360.
Yeah. 0 would repeat if we were at 360, so 359.9999999 is the largest true bearing we'll get. Cool. What's the largest number we'll see in the middle of our compass bearings? 89.99999. Good. So our compass bearings, the main thing that we need to understand with our compass bearings is they always measure away from the north-south line. Cool? Happy with that? Always measure away from the north-south line. The opposite of our unit circle, we're always measuring away from the horizontal. With our compass bearings, we're always measuring away from the vertical. Cool? So north 89 degrees west, is that closer to west or to north? I'm basically heading which direction? North 89 degrees west. West. Very good, Tom. I'm basically heading west. Cool? Because I'm 89 degrees away from the north-south line. With these, I think most of us understand that. Where we get caught is knowing how to apply those to our questions. So these are some general tips, and you'll probably see them in the solutions that you're going through. This is really important. Draw little plus signs at every point. It's particularly important that, again, we get our north and our south line. I like to represent them as dots, because that helps us do the next part. If we're doing that well, we can find opportunities to use our Z rule and our 180 degrees in a straight line rule. Cool? Happy with that? Yep. I also could have put this one in there, but I didn't think I needed to. Make sure we're drawing accurately. A few of the more cluey people in the room have identified that some of the questions have angles that don't look like 90 degrees, and their angles will say 91.3. Like that doesn't look anything like a 90-degree angle. Very good. We don't write very good questions, but when you're in exams, like external exams and your Unit 4 exams, we have to go through a pretty strenuous process to ensure that we're not misleading you with that sort of stuff. So if your graph doesn't look correct and you've drawn it accurately, you find errors along the way. Sweet? So draw accurately, use a ruler, label, and use a few diagrams. If you're doing a big messy one where you've got, A, you've got your dotted line, and then you've got B, and you've got a dotted line, and you've got a dotted line, and that guy there and that guy there, and you're getting all these weird angles like that. Nothing wrong with that for your first diagram, but make sure you're setting up a second diagram with your triangle with your known values so you can clearly see what you have. Happy with that? Due means directly. So if you see due east, due north, due south, due west, means directly west, directly south, directly north. Happy with that? And the last one, northeast, northwest, southwest and southeast, all just mean directly northeast, which means 45 degrees. Cool? Halfway between north and east, or north and west. Happy with that? No dramas? Sweet, good. I'll leave you to it.